Hello there, and welcome to the SVL for Beginners video series, brought to you from the CCG office in Germany. I'm Guido Kirsten, Principal Scientist at Chemical Computing Group and teaching molecular modeling and cheminformatics for 100 years now. A bit less if I don't count college. For this course, you only need an installation of Mo and a valid license key from Chemical Computing Group. This series is intended for beginners, so I will go through all the basic concepts of the programming language like functions, keys, and the coolness of SVL, vectors. We will discuss how you can customize Mo with stylish menus and write scripts to accelerate your research. You should have a background in chemistry because I will assume that you are already familiar with terms like chirality, hybridization, and know what is a conformation. The course is broken into chunks, allowing people to come in and take the pieces they want. I will not reveal any new secrets about SVL because all the information has already been released in our documentation. But I will bring the magic together and create it as a story for you for the work you need to do. In this video series there will be challenges because I don't want you to just watch the videos like a sitcom on television. You have to become an active learner. You cannot learn to play guitar without just touching an actual guitar. If you are a chemist thinking about learning a programming language, why should you learn SVL? Programming is essential in today's research. With programming skills, you can be more creative. You can easily test new ideas. Today, we have to deal with large datasets. To manage these datasets, we need the support of computers because you cannot do it manually anymore. With programming skills, you can automate common tasks inside one application, saving you dozens of clicks. Today, we have to deal with multiple applications from many different areas like NMR, crystallography, biology. And to integrate those applications into a common interface, you need programming skills. But most popular languages, JavaScript, Python, C#, and the family of languages around it, are not designed for chemistry. In chemistry, we need a powerful molecule object structure. We need a complete set of concise chemistry functions. We need flexibility, vectors as a loose data type. We also need to be independent of the operating system because we have to use Linux boxes, Windows machines, and Macs. With programming skills, you can optimize your Mo usage. You can customize Mo with new menus, new scripts. You can integrate Mo into your IT backbone. With programming skills, you can use Mo in batch mode, consuming only one license token in contrast to 3 from the graphical user interface. So let's get started. Mo is a kind of virtual machine for SVL. Each menu entry, each button sends an SVL command to the runtime. But how can you enter commands? The fastest way to get access to the SVL command prompt is to hit the spacebar on your keyboard. And this will turn the menu bar into an SVL command prompt where you can enter SVL commands like so. This does not work in the main window only. In fact, it works in any Mo window. So if I open the sequence editor and hit the spacebar, I get the SVL command line and I can enter SVL commands. After a command has been entered, the command prompt is closed automatically. If the command returns something, I cannot see it that way. That's why my preferred way to interact with the SVL command interpreter is the SVL command window, which you can open by clicking on SVL in the menu bar. And this opens the SVL command window. At the bottom, you have the SVL command prompt. On top, you have the output window, where you find the results of the SVL commands you entered. As a beginner who has used the graphical user interface until now, your biggest problem is that you are not familiar with the SVL commands, you don't know what to enter. But Mo makes it easy for you, because there is a way to echo the SVL commands issued by the menu entries to the output window. So let's try to guess the command. If I enter echo, there is a command and file autocompletion with tab. So if I hit tab on the keyboard, nothing happens. That's because SVL is case sensitive. So let's try echo with uppercase E, hit tab again, And you see the command has been auto-completed to echo many commands. You wouldn't have guessed that. So let's set it to 1, press enter. And if I click on a button now, for example on close, you see that the command is printed in the output window. Now we are really ready to get started. Let's do a simple task. Loading a complex from a PDB file, doing some modeling and saving the results to a file. So first I need to load a file. So I click on Mo File Open. That gives me the File Open panel. Here I can navigate to files on my hard drive. I can also load structures from Silo, the RCSB, or from other sources. And in the Mo installation directory, we have a subdirectory where we store example files. So I navigate to $mo sample mol, scroll down a little bit, and you will find 1m17.pdb.gz. Nothing special, just another Kaizen structure. I click OK, and the structure is loaded. Now let's center it on screen. Maybe we have a closer look at the binding pocket, and you see whenever I click on a button in the button bar, the corresponding SVL command is printed in the output window. Let's check whether that also works for the menu bar. So, for example, I select the ligand, and you see the command is also printed. Maybe as a last step to give a nice workflow, we can minimize the ligand in the absence of the receptor. And finally, we need to save the file. So I go to File, Save, and I call it 1m17 minimized.mo. minimized.mo, and I close the window again so that we are ready for a new start. So our task is now to re-execute the workflow without using the mouse, just SVL commands. So let's have a closer look at the SVL command window. You see the first command that has been executed is run OpenSVL. So before you type this in, I should show you a little trick. So if you highlight the command and right mouse click, you get a little pop-up menu, and there you can copy the command to the clipboard. So I go to copy to clipboard, and in the command prompt I can use Ctrl V. If Ctrl V is not working for you, try Shift Insert to paste in the command, press enter, and it will open the File Open panel again. But that's not what we wanted. We want to read the file without user interaction. So we need a different SVL command. And as we cannot see it from the output window, we need more information. So it's always a good idea to check the documentation. I know read the fucking manual is not what you wanted to hear, but it's not that bad. So I go to Help, Function Index, and that gives me an alphabetical list of all SVL functions released with Mo. There's also a page which groups the function together in categories. And as we are looking for a function to read in a file, it probably starts with R, so I jump there. And if I scroll down a little bit, I find a family of functions, all starting with read, then an identifier for the format, and here among them I will find read PDB. So I click on the function name, and that opens the page with the description of the function. And I see here the syntax is read, identifier for the format, and file name. I also see there's different family of functions starting with write, identifier for the format, and the file name. So let's keep that in mind because we will need it at the end of our workflow. Let's close the documentation again. And now I need to read in the file. So let's type in read pdb, and now the file name, it was $mo, and then sample mol 1m17.pdb.gz. Press enter, and the structure has been loaded. So the next thing is that we need to center it on screen. So I can highlight the next command, copy it to clipboard again, use Ctrl V, press enter, and we have it centered on the screen. Next is the side view. So let me
type it in. So that is render isolate empty square brackets. And the next is select a ligand. So before I type it in, I can also use the arrow keys to navigate through the history of commands that have been used, and I can go back to select a ligand, press return, and the ligand gets selected. And there is another way. If I have used many commands, I might have to use the arrow keys multiple times to get to the command, but I can also type in the command history, which will print out the command history to the command line. And here I can see any command I have used, and also it will precede the commands by a number. So I see #10, that is the minimization in the absence of the receptor. So after history, I say #10, type enter, and it will re-execute the command. Isn't that cool? So finally, we need to write the results to disk. So I use write-mo. That's a function we spotted in the documentation, and I call it 1m70 batch minimized .mo. Press return, done. So we have now found a sequence of SVL commands which can execute our workflow. But if I would close the Mo session, all the commands would be lost. So I need a way to store it. And that can be done in a log file. So I need to start a log file. And I have to give it a name, 1m17.log. And now every command I type in will be reported in the log file. And I could again use the arrow keys to go back to read PDB and enter the commands again, but I also can use history, which will print out all the commands, and then I can close the log file by using log file with empty square brackets, and now all the commands are saved to the file. And that would be a good starting point for writing a script. So let's have a look. So all the commands are here, and I can use that to write a script. So let's summarize what we have discussed. I showed you how you can access the SVL command prompt by pressing the space bar, and I introduced you to my favorite way of entering SVL commands using the SVL command window with the SVL button in the menu. We briefly discussed the layout from the command window with the command prompt at the bottom and the output window on top. I showed you how to navigate around in the command window using the right mouse click pop-up window and also the tab file command autocompletion, scrolling through the command history using the arrow keys, and shift insert if Ctrl-V is not working for passing from the clipboard. We also used echo menu commands to force all the menu entries and buttons to print their corresponding SVL commands to the output window. We used the history command to print out all the previously used SVL commands, and we printed them into a log file, which we started by log file with a file name, and we closed the log file with square brackets afterwards. I pointed you to our documentation, where in Mo help function index you find the alphabetical list of all the released SVL functions, and in the overviews you find a grouped list. In the documentation we saw the description of the read functions, which start with read, identifier for the format, and the file name, which load in the content of the file into the Mo system, and write identifier for the format, and the file name writes the content of the Mo system to a file. I mentioned that we have some built-in shortcuts for directory, so Mo for the Mo installation, home for the user's home directory, and TMP for the directory where you store temporary files. Okay, up to this point, you have been sitting back watching me doing all the hard work. Now it's your time. Get your feet down from the desk. It's time for you to struggle. Struggling is how you learn. It's time for the first challenge. So here's your challenge. Execute the following steps using only SVL commands. Load in mo sample mol 1m17.pdb.gz. Annotate the sequence. So a little hint, the menu would be mo protein annotate sequence. Then use side view and save the result as 1m17 underscore annotated.mo. The solution will be shown in the next video. You can solve the challenge based on what you have learned during this video. Don't cheat. If you get stuck, feel free to rewind this video as many times as necessary. If you have found the solution, you can proceed to the next video, where I will show you my approach on solving this challenge. See you there.